This is from chapter Real Number exercise 1.1. Question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. So remember, it is talking about odd integer, positive odd integer. So any odd number, any odd integer can be expressed in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. That have to show. And it can be shown with the help of Euclid's division algorithm. So let me tell you about Euclid's division algorithm first. Euclid's division algorithm says that any integer, positive integer, any positive integer can be expressed as bq plus r. Where r is always greater than equal to 0 but less than b. Say for example, any positive integer, suppose 30, it can be expressed with any divisor. This is b is the divisor. With any divisor, suppose 7. So you can express as 7 4 is 28 plus 2. 7 represents b, 4 represents q, plus 2 represents r. And it can be rewrite like this also. 30 is dividend, 7 is divisor, 7 4 is 28 and remainder is 2. So you have to be very clear about this. So it can be, we can take another example. Suppose 30 is divided by 6. Then it will be like this. 6 5 is 30, remainder will be 0. And it can be rewrite like this in the algorithm form. 30 is equal to 6 into 5 plus 0. 6 into 5 plus 0. But here you remember, the remainder 0 is always less than this divisor. And here also you remember, the remainder 2 is always less than 7. That is, remainder 2 is always less than 7. That's why here it is written r remainder is always less than b. R remainder is always less than b. And sometimes r is greater than 0 and equal to 0. You see here r value is, this is greater than 0, 2 is greater than 0, and r value is sometimes 0. So that's, you need to be very clear. So once again I'll tell you, any positive integer can be expressed like this in the form of bq plus r with any other positive integer. Any positive integer can be expressed in the form of bq plus r. After knowing this, you can come back to the question again. So here what I have to show, positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. So let us take in a solution. Let a be a positive integer. So according to Euclid's division algorithm, a can be expressed with any divisor. Here the divisor is very clear, the divisor should be 6. So A can be expressed as 6q plus r. So I assume A is a positive integer. And according to Euclid's division algorithm, positive integer can be expressed in the form of bq plus r. And I'm here taking the b as 6. So remember, when the divisor is 6, then the possible remainder are, what can be the remainder? Remainder may be 0, remainder may be 1, remainder may be 2, remainder may be 3, 4 or 5. Because so whenever any number is divided by 6, the remainder will be less than 6. Maybe 0, 1, 2, 3, 4, 5. So there are 6 cases is there. So now I'll take, and the remainder is 0. Then the positive integer will be like this. Then A will be 6q plus 0. And in case of second, when the remainder is also maybe 1. So when the remainder is 1, then the positive integer will be in this form, 6q plus 1. Similarly, when the remainder is 2, then A will be in the form of 6q plus 2. Remainder is replaced by 2. So similarly, when the remainder is 3, then the positive integer will be look like this, 6q plus 3. When the remainder is 4, then A will be equal to 6q plus r, 6q plus 4. And when the remainder is 5, A will be equal to 6q plus 5. See, these are the 6 possible cases. Now you observe all these positive integer, these 6 possible positive integer. In this 6 form, you see which one is even and which one is odd. You observe carefully. Here 6q plus 0, that is only, this is same like 6q. And 6q means 6 into some integer. That is, it is giving a multiple of 6. Multiple of 6. Just you remember any multiple of 6. 6 1 is 6, 6 2 is 12, 6 3 is 14. 6 3 is 18, 6 4 is 24. All these multiple of 6 are divisible by 2. So all these are even number. So ultimately 6q plus 0, that is, this is a even number. What about the next? So let me write here even. What about the next? We know 6q is multiple of 6 is even number. And when the even number is added by 1, surely it will be odd number. And here also the same, when 6q is a even number and it is added by 2, you will get an even number. Suppose any even number, when you add it by 2, you will get an even number. So this is also even number. And what about this? 6q is even number, we know, but added by 3, it will be odd number. If you add 3, it will be odd number. And here this is a even number plus even number, 4 is also even number, then it will be even number. And 6q is a even number added by 5, it is a odd number, so it will give 6 cube plus 5, it will give an odd number. So now you observe all these possible positive integer which are even and which are odd. This is odd, this is odd, and this is odd. So what you found? Odd positive integers are 6q plus 1, 6q plus 3, and 6q plus 5. So hence it is proved. Hence it is showed. It is asking you to show that odd integer, positive odd integer are 6q plus 1, 6q plus 3, and 6q plus 5. You have to show. We found the same. Positive odd integers are 6q plus 1, 6q plus 3, 6q plus 5. Those are odd. You check this: 6q plus 1, 6q plus 3, 6q plus 5. So all the odd, positive odd integers are in the form of 6q plus 1. So I wrote down here. Therefore, any positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Hence, short. Thank you.